Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to discuss BLDC motor. We are going to see some basic concepts related to BLDC motor, where BLDC stands for a brushless DC motor. So far now we have discussed the motors, those were brushless motors. So motors will be having the brushes. So what will be the difference when the motors we use are having brushes and the brushless motor that we are going to observe in today's video? So we'll see what is brushless motor is, how it is different from the normal motor, and what are the different characteristics, what are the application, advantages and disadvantages of a BLDC motor. So let's first discuss some important aspects of a BLDC motor before we go for the actual construction understanding of the BLDC motor. BLDC stands for brushless DC motor. That means it do not have the brushes in it. It has a semiconductor control, is used for the controlling the stator's current in such a way that maximum torque is obtained at a given speed. According to the different speed, the torque produced by the DC motor or the DC machine is always a different, because the speed and torque has a particular characteristics, particular relation that we have discussed when we have seen the VI characteristics of a torque and speed, when we have discussed the induction motor and different types of AC and DC motors. So here also we have a same concept related to BLDC motor. Only the thing is semiconductor control can be used to control the current of the stator, so that the torque will be produced is different for the speed given to it. Now let's see how the BLDC motor look like. This is the construction of a BLDC motor, where you can see this is connected. This is a circular where we have a stator with the winding, and we have a shaft and permanent magnet rotor. So basically stator has a three-phase winding. Now here, instead of one phase, we are using the three-phase winding, but the stator will be a stationary, as we have discussed earlier. Then we have a rotor is in the form of a permanent magnet. Here rotor is nothing but it is a permanent magnet. So how it is going to be operate? Basically what we need to have whenever it is a motor, it is completely depend on the rotation. So how the rotation will takes place, that will define the working principle of a BLDC motor. So we have to see rotor is the part of the machine that will rotate, and stator is the part of the machine that will remain a constant, or that will be the stationary part of the. But this rotating of the rotor is completely depending on the current produced across the stator, because the stator current will exert a force on a rotor to rotate it in a particular speed. So speed can be controlled by controlling the current across the stator. So according to this diagram, you can see shaft is the part of the motor. So basically this part of the motor will rotate in either clockwise or anti-clockwise manner, that we will see later on when we will check the working principle of the motor. But this part will rotate, that is called as a shaft, which will be connected with the different types of load which is to be driven by the motor. And this part which is having the three-phase winding, which is called as stator, will remain the stationary. BLDC motor also consists of rotor position sensors which produce electrical signals that indicate the current position of the rotor. BLDC stator winding is driven from an electronic drive, which is a three-phase inverter. Speed of a BLDC can be controlled by controlling its stator voltage, which can be achieved by controlling the DC input voltage of the inverter. Since the converting part or the controlling part is utilized by using the inverter, where inverter are designed by using the different types of thyristor family. So basically we use SCR to build an inverter. So this inverter is using to control the voltage across the stator. If you are controlling the voltage across the stator, current will be controlled, and due to the controlling the current, the rotation of the rotor will be controlled by it. Now here it is given that it has the different types of sensors connected on it. So these sensors are nothing but to sense some electrical parameter. So basically here electrical to mechanical conversion is necessary. So it will sense the electrical parameter which indicate the current position of the rotor. What is the rotor's current position? That can be given by the sensors connected to the BLDC motor. Now let's see how these sensors are connected on the BLDC motor. So here you can see these are the sensors placed in a different manner. So basically sensors are placed at the shaft. The permanent magnet brushless DC motor use Hall sensors with a 60-degree electrical spacing. So 60-degree electrical spacing, the sensors are placed and these are placed on the rotor part. The sensors produce a logic 1 when they expose to N type of the rotor and logic 0 otherwise. So whenever there is a rotation takes place, it produces an N pole and S pole. Pole and S pole will get produced. So basically whenever the sensors are exposed to N type of the pole, then it produces 1. But if they are exposed to the south pole of the magnet, because it's a magnet and it should have 2 poles, when it is exposed to the south pole, S pole, then it produces 0 logic. This is how the sensors placed on the rotor will work, and they always placed with a 60-degree electrical spacings on a shaft. So the work of the sensor is to send some electrical parameter, and this electrical energy will define the position of the rotor. In BLDC motor, the driver circuit operate on a DC supply. Since it is a DC motor, obviously its supply voltage will be in a form of a DC. The field produced by a stator and rotor remains stationary with respect to each other. The torque speed characteristics is similar to that of a DC motor. This motor does not have brushes. So since it is a brushless, it do not have brushes, and its torque and speed characteristics is similar as the torque and speed characteristics of the brushless DC motor are similar as the DC motor we have discussed in module 4. You can refer that video to understand the torque and speed characteristics of a DC motor, which we have already discussed. Now here it is given that the circuit is operate on a DC supply, and its field current and armature current, or the stator and rotor, since they are stationary, they will remain stationary with respect to each other. Now we have 2 different types of a BLDC motor. First type is a unipolar, which is called as a half wave BLDC motor, and the second type is a bipolar, that is called as a full wave BLDC motor. Now let's see the basic operating principle of the BLDC motor. Here you can see we have a stator winding and we have a rotor winding. So this circle represents the stator winding, and the inside block represents the rotor winding, which is nothing but the permanent magnet, and where you can see there is one north pole and there is one south pole. Now if we are using stator winding with a 3-phase, there are 3 phases are connected: phase A, phase B and phase C. Because our stator is having 3-phase winding, these 3 phases are nothing but A, B and C. So input supply is given to this particular windings. Depending on that, current will be produced across the stator, and that will move, or that will rotor to rotate in a particular manner. Now as we have discussed, whenever there is a phase A is energized, stator poles S and N are created. So to create the south pole and north pole of a permanent magnet, there should be magnetic field present over it, and to the magnetic field present you need to supply some energy, that is 3-phase AC supply, to be given to the motor. Whenever this phase is energized, the south pole and north pole will be connected. Now stator S pole repel rotor S pole. Now if the poles are similar, they always repel each other. You all know about magnets that different poles attract each other and the similar poles repel each other. So if south pole and south pole is coming together for the 2 different magnets, then they will repel each other. But there are 2 different poles, that is one north pole and one south pole is coming together, then they will attract each other. Now you can see here when phase A is energized, this is a part of a stator. So stator S pole repel rotor S pole. Now this is the rotor S pole, so it will repel away because phase B is not energized. Similarly, when phase B is energized, the S pole present over here, this stator pole will repel this rotor pole away and it will attract N pole away. So likewise, first phase A will be energized. So A will throw away this S pole and try to attract this N pole. So the arrow is shown in this manner. Second, phase B will be energized. If phase B will be energized, this will try to repel this south pole from this particular phase and it will try to attract N pole. So this arrow is shown. Similarly for phase C also, whenever the S comes near to the phase C, the S pole of the stator will try to repel the S pole of the rotor, and in this manner this particular magnet will rotate in this way. So this particular magnet will be rotating in a clockwise direction, and this is how the rotation of the rotor takes place. That is nothing but rotation of the motor we called. So clockwise torque is produced. Since there is a field produced, since there is a magnet produced and magnet is rotated by the phase poles, then it will rotate in a clockwise. So clockwise torque will get produced. The magnitude of this torque is given by T is equal to K, where K is the constant, phi S into phi R into sine theta, where K stands for K is constant, phi S is nothing but the stator field flux, phi R stands the rotor field flux, and phi is nothing but torque angle. So this is what we know, that field or the flux will be produced across the field whenever there is a current flowing through the windings of the stator. This shows that the torque is sinusoidally proportional to the torque angle theta. Magnitude of the stator field flux is proportional to the stator current I1, and the rotor field is a constant. We have seen that by controlling the current and voltage across the stator, we can control the speed. So basically we can control the torque. So the magnitude of the stator field flux is proportional to the stator current I1. So it is known as T is equal to K1 into I1 sine theta, where I1 is nothing but this is the current across the stator. So the stator phase are energized in a sequence A, B, C, A, so as to have a clockwise rotation of the machine. As we have seen, we have a 3 different phases, A, B and C. So each and every phase will be energized in a sequence. So first A, then B, then C. Again A will be energized, again B and C. So this is how the rotor will rotate in a clockwise manner. What are the applications of a BLDC? So first, it is used in a computer peripheral equipment. Different computer peripheral equipment, we need to have some small motors to be placed for some reason. So it can be used in a computers. Secondly, instrumentation and control system. In an industrial application, we should have the instrumentation properly to measure some physical parameters and then convert them into the electrical signal. This electrical signal will be produced, and according to the electrical signal, the actions will be taken. For example, if the temperature should be maintained a constant in particular room, then this temperature should be measured. We always use a transducer to measure this physical quantity, and the electrical signal will be produced according to that, and that will be processed. So in such kind of instrumentation, we need to have BLDC motor. Then we can use it in a control system to control some kind of parameters. Also, we need to have a BLDC motor. It is used in a electric power steering too, because it is a brushless. There is a less power consumption because of the absence of a brushes. So always it has some advantages over the brushless motor. It used in a air conditioners, biomedical instrumentation, in aerospace. Since they do not have brushes into it, it will be less noisy. In biomedical applications, you know that the noise should be less, so BLDC motor can be utilized in a biomedical instrumentation. Now let's see what are the advantages and disadvantages of the BLDC motor. Advantages of the BLDC motor: no maintenance is required due to absence of brushes and commutators. Since there are no brushes, low maintenance cost is required. Low inertia due to low friction. No brushes, there will be low friction. If low friction is there, inertia will be low. Higher maximum speed due to low friction. If friction is less, definitely the speed will be maximum. High efficiency, that is more than 75%. That means the efficiency is nothing but the input supply is given and how the rotation or how the speed is controlled, or the maximum speed. So basically output upon input will give you the efficiency. So for the best possible input there will be best possible output. That is what we define as a efficiency. So efficiency is maximum. It has a reliable operation. It has a long life. Since there are no brushes present, so lot of parameters those are not be present for the brushless DC motor. For example, we have seen the less maintenance is required. If there is a less friction, then the device will work for a longer period of time, so it has a long life. Speed and position can be controlled. Its speed and position can be easily controlled by changing the input supply given to it. But it had some disadvantage. It is expensive. Because of so many advantages, the machine is expensive. It has a complex construction. It need a complex electronic controller. Controlling of the machine will need to have some complex circuitry, and that is kind of disadvantage related to BLDC motor. So I hope you have understood what is BLDC motor is, why it is called as a brushless motor, because it don't have brushes, how the motor composition look like, how the working principle is, what are the different characteristics that are important in a different kinds of application, and what are the advantages and disadvantages of the BLDC motor. Thank you for watching this video. Stay tuned to Ekeeda. Do subscribe Ekeeda. Thank you so much.